So I'm going to tell a bit about static site generation. First, a little bit about me. I'm Denis. You can find me on Twitter and GitHub and elsewhere. Just Google. Like many of you, I'm a software engineer, and I am the author of Nanoc. Nanoc is a static site generator, which will be the subject of today's talk. So I know that many of you, or at least a few, have already used static site generators. But for those who don't, I'm going to give a quick overview of what a static site generator does. So when I write content for my website, then I prefer to write it in Markdown. And Markdown is a file format which is basically plain text. And it looks like this. So that's one paragraph followed by a list. And in that paragraph, there's an emphasized word. And that Markdown document can then easily be converted to an HTML fragment, which looks like this. So you have actual HTML coming out of there. But that HTML fragment is not entirely valid HTML yet because it's lacking a header and a footer and a sidebar. So that content is in a layout. And the layout looks, or could look, a bit like this. This is a really, really basic example. So at the point where there's a yield statement, that's where the content is going to be inserted. So you have the HTML fragment and the layout, and both of them will be combined together in order to form the final HTML document. And that document will then be written to disk, and you can then upload it to any web server. So that's really easy. That's a really easy way. That's a simple way static site generators work. Of course, it can get a bit more complex than that. So my experience with static website generation started when I had a VPS, a virtual private server with 96 megabytes of RAM, and I didn't want to keep on using PHP for my websites, so I wanted to use Ruby. But unfortunately, 96 megabytes of RAM really is not enough. Ruby is way more resource intensive than that. So it was too slow. Basically, I couldn't host my Ruby website on this VPS, so I had to take a different approach. But around that time, a friend of mine, who's sitting right there, wrote a script. Sorry, not you. Wrote a script for generating static sites. So he made a simple script, and that generated just static HTML, which was really easy. I got inspired there and decided to take the same approach for Nanoc, which is my own project. And since it's written in Ruby, and Ruby is a programming language that originates in Japan, I have also included the katakana, which means that you now know how to pronounce it properly, right? And also for last weekend, there's a new Nanoc website and also a new Nanoc logo. So after 6 years, it finally has a logo. And I even have stickers. So if you want stickers, come get some. So Nanoc is not a CMS. CMS is a content management system. So that's not what it is. But what is it? Well, it's a static site generator, and I propose we start using the term SSG from now on, because static site generators are getting more popular, as I will demonstrate later on in this talk. So I think SSG is a really nice abbreviation. And this talk is going to be all about SSGs, and I will not be saying static site generator in full, because I just stumble over my words, as you can see. All right, so the roadmap for this talk is first, what are static site generators? I've already explained a bit there. What are they capable of, because they're really powerful. And lastly, I will explain something about the lessons I've learned, and also future work, because there's still a lot to be done there. So what are SSGs? So I already mentioned that basically you have a directory with lots of markdown files or markdown-like files. They look like this. I've shown you, but here is something else. You can also assign arbitrary metadata, so I've included a title here. And the layouts also include that metadata, so that item title will come in the title tag in the head, and a bit like this, right? And then it will be written in a directory structure like this. Here I've opted to create index.html files, so that you have a clean URL structure. That makes it sound really simple and not powerful at all, but you can build sites like, well, of course, the Nanook website itself, which is not built using Drupal. There's the GitHub developer resources. The API documentation is all written in Nanook, even though GitHub has their own solution for a static site generator called Jekyll. They prefer Nanook for their documentation because it's much more powerful. The Miss Online website is a website I built a few years ago, and it demonstrated that it was possible to build a multilingual website without, just from scratch, without modifying Nanook itself. The app.net documentation and the Flutter documentation also written using Nanook. One I'm particularly proud of is that Disney's Ugly Betty site is all made entirely with Nanook. I'm not a fan of Ugly Betty, but I like the site. There's pre-API documentation, and of course, as of this edition of FOSDEM, there's the FOSDEM site itself, which is built with Nanook. Hooray. But I've been talking about Nanook. Nanook is not the only tool out there. Here, just let it load a bit. I've made it deliberately slow. There's a few I would like to highlight. So of course there's Nanook, but there's also Jekyll from GitHub. They use it for GitHub Pages, so if you use GitHub Pages, then you will likely use Jekyll. Octopress is a framework built on top of Jekyll for blogging, basically. It gives you a starter kit, so you can really easily get started with blogging. Middleman is also pretty popular in the Ruby community. I think it's my main competitor these days. And there's a Haskell, which is written by a friend of mine. It's written in Haskell, and it's really popular in the Haskell world. So if you like Haskell and don't like Ruby, then you should give it a try. Unfortunately, this list is incomplete. I already updated this list, but I then had to re-highlight individual names of static site generators that I wanted to talk about. But in the meantime, there are 2 new static site generators, so there are a lot of new ones turning up, and I didn't want to update this list anymore. Because maybe today there's another one popping up, you know. This is an example of a Jekyll site from GitHub Pages. Here's another one, a GitHub Pages template that you can use, and if you see a website that looks a bit like this, then it's most likely going to be built with Octopress. So why would you use static sites? Because they're obviously less dynamic, as the name says. Well, they are very fast because you compile your site to static HTML. It's served really quickly. Your HTTP server will also include the proper last modified and e-tag headers. It's secure. You can't hack a static site. There are no exploits there because there's no code running. It works with your own tools, which I think is really important, so you can edit your content with, for example, Vim or Emacs or Sublime Text or whatever you prefer. Your content is in plain text, so you have your content. It's not in some kind of weird format or in a database that you don't know the schema of. It's really easy to deploy. Just upload it, or rsync or whatever. Easy to preview, so you compile it to your local computer, and then you can you have the files, you can see whether they are okay or not. And it makes collaboration easy, which I will demonstrate with a screenshot from the GitHub developer site, which is open source, and people send pull requests, and modify that way. So it's become a community open source project, basically. So that was static site generators like in overview. So what are they capable of? What makes them really, really cool? They allow arbitrary metadata, so I've already shown you that you can add title to a blog post. That's nothing special, because if you can't assign a title, then your CMS or whatever is useless. But I can also write metadata like this. This is a review I wrote for Braid, which is a game, and I reviewed in 2008, and I gave it 5 out of 5 stars. This is YAML, so you can nest it, and you can put in there anything you like. And if you have a list of reviews, then you can iterate over all your reviews and then print the proper number of stars, and followed by the review title, etc. And you're not limited to what the CMS gives you. You have full power of your metadata. And this is the result, of course. Right, filters is another really useful thing. So I've already shown you that you can use Markdown. You can also use text style. And for the layout, you can use ERB, or you can use Mustache, which is a bit prettier. Hamel is much more compact, also pretty popular. And you have filters like colorized syntax, so if you have a bit of code on your website, it's marked up using class equals language Ruby, which is what the HTML5 specs says you should do. Then Nanook will pick it up and colorize it so you have really pretty colors. I hope the colors are readable, but they are readable from here. Okay. Typo Groovy is an example of a library that cleans up your text. So basically smart codes, proper dashes, proper ellipses, etc. And you can write your own filters really easily. This is an example I use a lot. It's a sensor filter, so when you run it, it replaces all instances of Nanook sucks with Nanook rocks, which has the nice advantage that if you Google for Nanook sucks, you only get instances of the Nanook documentation. So now you have these filters. How do you tell Nanook when to use them? That's defined using rules. So here you match on everything. So for all items, if the item kind equals article, then you use the blue cloth filter, which is a Markdown implementation, followed by the default layout. You can also process binary items. So here I say run image optimize filter. That's not a built-in filter, but you could say maybe PNG crash or something. And you can also create multiple representations. So for the same item, you're creating another output file, but this time it's a thumbnail. And to get to the thumbnail, you run a scale filter with a width of 140 pixels. And here's another example. You could say, take all my blog articles, and I'm creating a separate output file for an MP3s. You could say, okay, I'm running this save filter, which on macOS 10 could take the text and create an AIFF file containing basically the spoken text-to-speech of that article. Then you run lame to get an MP3 file. This is absolutely useless, and I would not recommend doing it, but it shows the power that the rules and the filters provide. I assume most of you are familiar with makefiles. So you may think, wow, this is pretty much what makefiles offer you. It's similar, but there are a few differences. With makefiles, you define what targets you have, what output files you have, and then you also define how to get to the output files. With rules, you just specify how to process the input files, and you don't care what the output is or where it's written to. You don't define that. So that's a pull versus push system. I also believe the rules have a cleaner syntax. There are no weird variables like $star and greater than or whatever it is. I can never remember. And the Nanoc rules offer dependency tracking. So if you have one item that includes content from another item, which then includes content from another item, and you modify this item, then the dependencies will be tracked and the right items will be recompiled. Helpers, a bit like Ruby on Rails. So you just have a module that has some functions. So here I have a tagging helper with a function items for tag, which you can use in basically whatever you want. So here's a tag page. You can say a header tags for this tag, or items for this tag, and then you just run. This was supposed to say items for tag, not tags for this tag, but you just iterate over all the items and print them and link to them. So you have a link to helper as well, so you can link to an item directly. And this is all compiled statically. So with all this that I've shown you, you can build a static site pretty quickly. And once you start doing that, you will find that your workflow is going to have changed quite significantly. So there's two steps, basically, when you're working on a website. First of all, you do the development, you write content, and at some point you decide, okay, we are going to publish the website. So while you're doing development, of course, you want to use version control because you have plain text files. That's ideal for version control, which means you have a history of your project, but you can also start using branches for a website. That's something a traditional CMS cannot do. Also, of course, no history, let alone branches. And if you throw your website on GitHub, then you can use pull requests as well. And people can fork your project, write some new content or fix typos or whatever, and ask you to merge their changes into your project. Okay, so that's how development works. If you're preparing for a release, then you will obviously want to preview your site. So you compile your site, you can preview it locally. That's pretty obvious. And secondly, the release of Nanoc that I made last weekend supports checking, which basically means automated testing for your static website. It checks like valid HTML, valid CSS, valid internal links, quite important, valid external links, etc. It's also quite customizable. And lastly, then you have the deploy step, of course. You can use rsync, for example, which I prefer. Some people have their output as a Git repository, which they commit to again after compiling, and then push their repository, and they have a push or post commit hook on their server, which throws the site live. One feature that I like about Nanoc has proven to be really useful is data sources, which basically allow you to take data from any source and import it into Nanoc. So I'm going to give you an example of the Nanoc website. So the Nanoc website has 3 data sources. FS is the file system. That's what you normally use, just content on your file system. There's the command line interface data source, which loads. Okay, so the Nanoc command line interface is defined using an internal Ruby DSL, like this. The actual commands that you use while using Nanoc on the command line are defined this way. You also have a run block, which is executed when you invoke the command. But this data, this definition, is used to, first of all, generate command line help. So if you say Nanoc help some command, then it will show you the help with pretty colors and all that. But you can also use it as a data source, and then you can generate also help on your website. So this is an example. I define the command in exactly one place, and then it's propagated to the command line help and the website. Filters are documented. Basically, all my source code is documented, which is really cool, because then you can generate command line. You can generate like API documentation. Here's an example of a filter, which is really nice, but it's nice. This documentation is nice if you want to start developing, but if you only want to use it, then this documentation sucks because you can't see the forest through the trees. So what I'm using to generate this is Yardoc. Yardoc is a Ruby tool that generates this HTML. It works in 2 steps. First of all, it takes the source code, generates a database containing the API documentation, and this API documentation is then converted to HTML. But Nanook can use that database, interact with it through a data source, and then import it in a Nanook website, and then you can generate really nice looking documentation, very, very focused, only take the parts from the API documentation that are relevant. So this is also automatically generated. And again, I document these filters only in one place, and it appears both in the API documentation and on the website. And the same is true for the helpers. Those are also documented. So this is basically an extract from the command API documentation. That's the data sources for the Nanook site. FOSDEM website also uses data sources, and they use 2. They have the file system data source, obviously, but they also have Pentabarf. And Pentabarf is a conference planning system that they use if you're a speaker, then you've interacted with it. It's basically, it stores speakers, rooms, tracks, events, anything. That's one database. And from that, so the FOSDEM website has a data source that loads the data from the FOSDEM, from the Pentabarf system, and then generates HTML like that, so you have all that data available in Nanook. It's all loaded, and then you can reorganize it, and so for example, you can create pages per track or per room or whatever, or even for an entire day, so this is all generated with Nanook. And this, if you want to learn more about how this works, then you can go to github.com/FOSDEM/website, which is an open source repository. So for the first time, the FOSDEM website is now entirely open source. I think that deserves an applause. You may have to set up Pentabarf to get it working, but at least it's out there and you can learn from it. So my experience with SSGs has learned me a few things about the advantages that are not so obvious. Static site generator is more than just Markdown plus a fancy layout converted to HTML. You can use it that way. If you want a personal website, then that's fine as well, but you can do much more, as the FOSDEM website proves. It's satisfactory in many, many, many cases. So the FOSDEM website is not a trivial website, but it's easier to maintain as a Nanook site than a Drupal site. And you may think, well, a static site is static, so it lacks dynamicness, but you can work around that with JavaScript, and that works fine in most cases. I wouldn't say in all cases, but it's more than enough, more than what you need. And the goal, I think more of a long-term goal of Nanook, and I think static site generation in general, is that if you have data, then you can use a tool like Nanook to publish that data on the web, convert it to something really nice, HTML, make it publicly accessible. So that's basically what the FOSDEM website does as well. They have only one place where they store their conference data, and that's not copied and pasted anywhere. Okay. While developing, now, of course, you learn things. That's one of the reasons why I still work on it. I've been working on it for 6 years, and I work on it to challenge myself. So I have a few lessons learned to share with you. First thing is about internal DSLs. So an internal DSL looks like this. This is the rules file is an internal DSL. So you say compile the about page, and how am I going to process this? With Cramdown, which is a Markdown implementation. As you may have noticed, there are a lot of Markdown implementations out there. I could come up with at least 3 ones, but that's not really relevant. But you can abuse this. So the rules file is supposed to be entirely declarative, but it's Ruby, so you can do evil things such as this. In here, I say, okay, when you've compiled this page, then you're going to write some content to another file that's completely unrelated, and you can start abusing the system like that. Those are side effects. There's really no way around that. I suppose that Haskell has the upper hand there, but you simply can't prevent that. People still do that. Another problem is mutability. So you could write a rule like this. I'm compiling all articles here, and if the item has no attribute called layout, then I'm going to set it to article, and then I use that attribute to find the layout, so I'm layouting it using the article layout. That looks fine, but the problem is that you're actually changing attributes here. So if that attribute is used elsewhere, then the result of the compilation might be different of whether this rule is run at the beginning of the compilation process or at the end. And it trips up the dependency tracker and so on as well. So what I did is I just freeze everything. So once compilation starts, you can't modify anything, which seems like a drawback, but it allows me to go into the compiler and optimize there and make assumptions, because I know that data is not going to change. And you don't lose any power and you don't lose any flexibility. Another issue is speed. So you may think, well, you have your site, it's compiled, it's on the server, you can't really go any faster there, and it's not Nanuq's goal, and you'd be right, but the actual compilation process itself obviously also takes time. And if you have a website with 2,000 pages and you need to compile that from scratch, then you still need to process those 2,000 items, and if they take a half a second, then you will have to wait. But there's no way around that. But there's still some techniques to improve that. For example, incremental compilation, basically meaning you only recompile what's necessary. So that reduces the complexity from linear in the number of items, or at least linear in the number of items, to linear, at least linear in the number of changed items, right? That makes it look trivial, so you only go look for the changed pages and recompile those, but that's not enough. So I have a few scenarios. For example, you have one page that has changed, obviously you recompile that page. But if you have a changed page that is included in another page, then you need to keep track of dependencies and recompile also the other page that includes the changed page. And what if you change the rules? If you change the rules, then you need to figure out what the rules change, what the effect of that rules change is. That's not trivial. Nanuq does that pretty effectively, I think. I do a bit of cheating there, but nobody notices, and it works perfect in all cases, I hope. But there's still some work to be done there as well. If you care about speed, then you should pick the right libraries or pick the right filters. So, for example, if you think that having smart codes is a good thing, then excellent. And you can use RubyPants, which is a Ruby port of SmartyPants, if that rings a bell. Basically, those libraries, RubyPants and TypoGroovy, make your code smart and proper ellipses, etc. But TypoGroovy is more than RubyPants, and they are both slow. So I've been working on an alternative of my own called FastAlec. I don't think even in alpha stage. I hope to release it in the coming few months. And the preliminary results show that it's about 100 times faster than TypoGroovy, so that's quite impressive. If you like coloring your syntax, if you have syntax that you would like to have colored, then you can use Pigmentize, which is the command line interface to Pigments, and there's pigments.rb. The Pigmentize filter shells out and calls the Pigmentize command line tool, while pigments.rb interacts with the Python interpreter directly from Ruby. And pigments.rb is way faster than Pigmentize. So here's an example. I did a pull request to the GitHub API documentation site, and I replaced Pigmentize by pigments.rb, and the speedup is amazing. Let me zoom in. So before it took 5 minutes to compile the site, and after changing Pigmentize to pigments.rb, it only takes 2.5 seconds. That is a huge speed up, and that's all because I used a different filter. So it's true that Nanook can be slow. Most of the time it is because you don't use the right filters. Not in all cases, of course, but picking the right filters, right libraries is a step in the right direction. Nanook is not finished. I've been working on it for a few years, and I think a few years ago I thought, okay, Nanook is finished, and I am not going to work on it anymore, because there is no work to be done there. But that's obviously not the way things work, so there is future work. For example, improving speed, and I can optimize a bit more there, and something I definitely want to investigate is parallelization. So as you may know, the Ruby interpreter is single-threaded, so basically you cannot take advantage of multi-cores, which is a big disadvantage. Of course, there's JRuby now, and Rubinius, and they both support, well, multi-threading, proper multi-threading parallelism, so I am going to investigate that. Maybe for the next release, I'm not sure. I think most people will have at least 2 cores or even 4 or possibly more, so this is really going to be huge. Supporting huge sites. Nanook was designed for websites that were maybe 50 or 100 pages when I started out. It can support up to like 1,000 pages or 2,000 pages. Those work perfectly fine. So the FOSDEM website is, I estimate, around 1,000 pages, maybe 1,500. I'm not quite sure. And that works perfectly, but a few months ago, somebody opens a ticket on my GitHub issue tracker, and they say, I have a site with a few 10,000 items, and Nanook cannot handle it. And there's reasons for that, because I never anticipated sites of that size to be compiled with Nanook. But I took that as a challenge, so I've been thinking about how can I improve that. And the goal for one of the next releases is to make basically Nanook allow arbitrarily large sites. So if you have 1 million pages, then it should be compilable with Nanook. That's going to be a challenge as well. Writing documentation is surprisingly hard. I think there's 2 levels of writing documentation. First of all, you just document everything and make sure the documentation is there and easy to find, okay. But the next level is presenting it and organizing it in a really proper way. And I'm getting there, but I'm on the first level, and the second level is still far off. So if you use Nanook and you want to contribute, then definitely let me know. And lastly, no, that's not the last point. I want to build an active community of contributors. I think there are quite a few Nanook users, but none of them really contribute much. And I'm still the main developer of Nanook. And don't get me wrong, I like doing it, of course, but it would be nice to have some more people, even if it is just to do to brainstorm and check ideas with, soundboarding, that kind of stuff. And lastly, I've had this idea for building a graphical user interface for Nanook for years now. Because sometimes people come to me and say, okay, I use Nanook and it's really great, but I want to use it for our company website, and the content is going to be updated by secretaries and PR people, etc. And they ask me, is this possible? Is there an easy way to let them do that? And there isn't. If you want to use Nanook, then you need to be able to use a terminal, and I don't think many PR people are Unix experts. So I'm thinking of building a graphical user interface like on top of Nanook, but that is going to be a real challenge as well, and it's going to be a lot of work. So if somebody wants to help out there, they're definitely welcome. So to recap what I've said, static site generators, they have really big obvious advantages. So they are fast, they are secure, very easy to deploy and preview, etc. But they also have some advantages which are not obvious at all on first sight. So you think, well, the metadata, okay, maybe that should be one of the obvious ones, but that gives you a lot of power, like basically free-form data that you can modify and compile, etc. Data sources also. Without data sources, the FOSDEM site wouldn't exist as it is right now. Because you compile the site up front, you can use checks. So the checks are the validating HTML, CSS, internal links, etc. And with SSGs, you can turn your website into an open source project. So for example, the GitHub developer site is open source. You can see the code, and when you have your own static site generator site project, then you can share code between others, and you can learn from others because the source code is there, and you can collaborate with pull requests, for example, etc. And with that, I would like to finish the talk. So if you think Nanook is interesting, then you can go and see the website, you can go and see the GitHub repository, and you can find us on IRC on Freenode, so feel free to drop by. Thanks. Are there any questions? I think you may have to use one of these. Maybe that works.
Yeah, not really a question, actually more of a comment. Which is a inline editing tool.
Yeah.
Because I've been doing my own static site generator, and I want to use my UI stuff.
Yeah. I have seen your project, and there's a few ones. I think I found the three ones. Those look really promising, so we should definitely talk. Any other questions? Yeah. Okay, thanks. This is the first time somebody comes to me and says, I got to know you from the Floss Weekly episode, so thanks.